Okay, so this is a talk about server push. We're going to start off by covering around some of the fundamental technologies that built up to where we are today, and then we're going to look at SignalR, and then we're going to try and look at practical application of SignalR. So, in the early days of the web, there was only really one way to make sure you had the latest email, price, or news updates displayed on your computer screen, and that was to refresh the page. Okay, so if we look at a traditional web request model, so basically you have a client, makes typically a GET request, returns some page HTML, usually a page, or alternatively you have a form post, which is a post action, and it also returns some HTML. In a traditional model, the only way to really reload the page, get new information, was to actually reload the page, which would initiate another GET request, produce some more HTML. Recently, there's been a move away from traditional request model to a more, with the rise of JavaScript-enabled single-page application. This is generally where we have a traditional web request returning HTML. It is followed up by a JavaScript AJAX request or request to the server, usually for JSON data. Then what happens is basically a JavaScript engine takes that data, makes changes to the DOM, so you see those on your page without having to traditionally reload the page. And we see that here, basically you've got an initial request, probably a GET request, comes out with HTML, it may also be returning scripts and whatnot, returned to run the JavaScript. Then you will generally have AJAX requests returned by JSON data, and something will happen on the client, maybe a page update to do with that. But note, in both these cases, the event that triggers the request always originates from the client. But I mean, what if I'm waiting for something to happen that will come from the server, such as a stock price update? The traditional way to get the update was to actually just reload the page. So there's just another representation of the same thing with the AJAX engine, single page multiplication, traditional web request. Okay, so wait a minute, we want to see updates, for example, new messages coming into our inbox without reloading the page. What are your options? An early way, but still in wide use today, is to add a JavaScript timer to your page to simply reload the data at a timed interval. So it may be a single page application, we're putting a timer into our JavaScript and we're telling it to reload and try and get new data at a timed interval. So a poll is called a polled operation, or a polling. In computer science, refers to actively sampling the status of an external device or server by a client program as an asynchronous activity. So we can see that in the diagram. We've got a request coming in from the client, a response. There's no updates, so there's no new added data. We have an event that actually updates some data, say in the database, but we have to wait this time. Now the time that we have to, between these two requests, is called the poll interval. So we can see the problem here that, well, can anyone see the problem with this? Anyone? Yes, so that's Andy's correctly identified the problem. You might have to wait the poll interval to get your update. So the smaller we make the poll interval, the more frequently and faster we'll get our updates. But the problem is, more requests are going to hit our server, and it's going to require more resources, and if there's no updates, we're still going to get a large number of requests hitting our server. So another attempt to, there's polling, just showing the poll interval. So another attempt to fix this problem is LongPulling. So with the LongPulling, the server does not terminate the connection straight away after the response data has been served to the client. The web server leaves the connection open so that if an event occurs, it can be sent out immediately. Otherwise, the event would have to be queued until the client's next request would have been received, as with traditional polling. So you've got traditional polling on the left and LongPulling on the right. So you see that the request doesn't get sent straight away. It actually gets held for maybe a long time until a timeout occurs, until an event takes place, and then the response is sent back. So potentially it has some advantages here. Most web servers often offer this functionality via CGI. The underlying connection mechanism for this approach is chunked transfer encoding. LongPulling itself is not a true push technology. LongPulling is a variation of traditional pulling technique, but it allows us to emulate a push mechanism under certain circumstances where push isn't possible, basically.
What's the downside to leaving a connection open?
I'm just about to get to that, but basically, the long pulling on the web is problematic with browser issues. It requires a large number of client connection requests must be tracked by the server, which has to maintain the resources to do this, and it creates a lot of unnecessary requests due to timeouts. Technologies that use long pulling, a good example would be XMPP, which Apple uses for its iCloud. So let's move on. Okay, so the next set of technologies to address this problem were push technologies. And an early push technology was called streaming. So an early technology would be hidden iframe, which was also called forever frame. A basic technique for dynamic web applications is to use a hidden iframe HTML element, an inline frame which allows a website to embed one HTML document inside another. The invisible iframe is sent as a chunked block which declares itself as infinitely long, why it gets the name forever frame. When an event occurs, the iframe is generally filled up with script tags containing JavaScript to be executed in the browser. One benefit of an iframe is that it works in every common browser. I think it's apart from IE, something like that. Two downsides to this technique are the lack of a reliable error handling method and the impossibility of tracking the state of the request calling process. There was another attempt at server push, which was called server-side events. Some of you might be familiar with it. It came out in 2006 with the Opera web browser, and it's now becoming a standardized part of HTML5. But again, with server-side events, browsers that would support it were patchy, and it had some problems. So, and then HTML5 came out. And we have HTML5 WebSockets. So WebSockets, they provide a full duplex communication channel. The WebSockets do solve a lot of the problems we're looking for we had with the previous server push techniques. But one of the main problems with them is a secure version of WebSocket protocol is only implemented in Firefox 6, Safari 6, Google Chrome 14, Opera 12, and Internet Explorer 10. So you're talking about reasonably recent browsers to support this technique. So what are the problems we're facing? The problem is too many devices and browsers to support. None of the previously discussed streaming transport technologies work across all modern browsers without negative side effects. The issue with WebSockets currently and for the next few years is browser support. This forces real-time web application developers to implement several complex streaming transport technologies, switching between them depending on the browser. So, what's the best solution? The best solution is really to start off with the ideal technology, which would probably be WebSockets in that case, and then, depending on what the client supports, drop down, and the server supports, drop down to the best option available. Problem with this is, though, that's actually, to write that on your own is quite a complicated implementation. It would take quite a sizable amount of time. So, what is SignalR? SignalR is a library for ASP.NET developers that simplifies the process of adding real-time web functionality to your applications. SignalR uses WebSocket transport where available, and then falls back to the older transports where necessary. SignalR is open source, it's available through GitHub. Well, you could certainly write your own application using WebSockets directly. Using SignalR means that a lot of the extra functionality you would need to implement will already be done for you. Most importantly, this means you can write your code and take advantage of WebSockets without having to create a separate code path for older clients that you're going to have to support with other technologies. SignalR also shields you from having to worry about updates to WebSockets, since SignalR will continue to receive updates. So we've got the diagram of SignalR architecture here. SignalR is an abstraction over some of the transports that are required to do the real-time work between client and server. SignalR connection starts at HTTP and then is then promoted to a WebSocket connection if available. A WebSocket is the ideal transport for SignalR since it makes the most efficient use of server memory. It also has the lowest latency and it has the most underlying features such as full duplex communication. But it also has the most stringent requirements between the client and the server. WebSockets currently requires the server to be using Windows Server 2012 or Windows 8 and .NET Framework 4.5 and above. If these requirements are not met, SignalR will attempt to use the other transport technologies. So if we have a look under the hood of Fiddler, what is actually being sent here, when a server-side code calls a method in the client, it contains the name and parameters of the method to be called. The client then matches the method names to the methods defined in the client-side code. If there's a match, the client method will be executed using the deserialized parameter data. So for the example we're looking at here, a method call is being sent from a hub called moveShapeHub, and the method being invoked is called updateShape. So we can see. I mean, what you have is connection hubs versus persistent connection. A connection represents a simple endpoint for sending single recipient grouped broadcast messages. A persistent connection API gives the developer direct access to the low-level communication protocol that SignalR exposes. A hub is a more generalized, so actually I'll go back to the previous diagram to see that. We can see that basically hub API is built upon the persistent connection API. Then the persistent connection API gives us access to the lower level features. A hub is a more high level pipeline built upon the connection API that allows your client and server to call methods on each other directly. SignalR handles the dispatching across the machine boundaries as if by magic, allowing clients to call methods on servers as easily as local methods and vice versa. Using hubs communication model will be familiar to developers who have used remote procedure calls or remote invocation before. A hub also allows you to pass strongly typed parameters, which you might want to use for model binding. So there are some cases where you might want to use a persistent connection over a hub. Most applications you would use a hub, however, in the following circumstances you may wish to consider a persistent connection. The format of the actual message sent needs to be specified. The developer prefers to work with messaging and dispatch model rather than a remote invocation model. Or we're converting a legacy application that has a previous messaging model and we need access to those lower level features to successfully port it. So some applications that would use SignalR. So why would I need to push data? What kind of applications use data pushing? Auction sites. So I used to work in auction sites. Basically what you have is a large number of people looking at, say, a coin in this case. At the end of the auction you have a lot of price updates and you want to be pushing those price updates because you certainly don't want thousands of people pulling intervals causing you a large number of server requests. Another good example is, so there's Android and iOS SignalR libraries, and basically you can create a proxy class in iOS or Android and it can talk to the SignalR hub and receive data much as the web page does. Another one is Sitecore. So when we're using the Sitecore dashboard, we've got a hub. So basically, if I believe, maybe some of the Sitecore experts could check this, but if I made a change on some data and an event was raised in Sitecore, if someone else was looking at another screen in Sitecore, they would also get that event raised. I believe that's the case. We can check it with Sitecore experts. Is that right?
When you speak content.
I got this from the Sitecore architecture blog, so I assume it's correct. And obviously we're looking to use this feature in our chat program with MeetMe. Okay, so I have a little chat application I made earlier here. I was going to quickly take us around it. So to add this kind of functionality to your website is actually very simple and easy. all I've done here is I've simply, this is a standard tutorial that you can get on the Microsoft website. Whoops. Sorry, I need to move this over. Okay, so this is a standard SignalR demo you can find on Microsoft website. What we have here is a standard MVC5 website. I've simply gone into here, I've added SignalR NuGet package. Installed packages, sorry. We can see Microsoft SignalR core components. We'll also see, so basically the various components of SignalR have been added. I just added the main SignalR library. So what do we have here? I've added a home controller with a chat view. We have added a hub, so we've added a hub folder, so we've added a hub. This is inheriting from the hub SignalR class. It's got one method called send, which we're going to call from our client to send a message to our chat message. So what we're going to do is we're going to send in the name of the person that's sending the message, we're going to send in the text message, and then with SignalR, we're going to remote call all the clients to this method, add new message to page. We can also see in here, when I added the NuGet package, SignalR has added some JavaScript libraries here to create the hub proxy, which you see in the other diagram in JavaScript. And we've created this page, which calls SignalR, creates a little box to do our chatting in. We establish a connection here. So we've got a callback method, add new message to page, that's going to append some HTML to our page when it receives an invocation for that message from the server. So, this is also working with Owen, which we had, I think we talked with in the previous chat, show and tell. So we have a startup for Owen, which just basically maps SignalR. And I think that's all we need to get started. So if I press play, I may have to change the path because it's not the standard default path. So I think it was home /chat. Okay, so it's asking me to enter my name. I'm going to say I'm Andrew. Oh, sorry, I'm giving it to the wrong window. Okay, so I have just, it popped up for the JavaScript alert asking me what my name was. I'm going to do that in Internet Explorer so you can see it. Okay, so my name this time is going to be John. And if I type a message now, for example, hi, and click send, we see it's automatically updated to the other page for remote communication. And obviously, Andrew can also say hi. Say hi, John. Whoops, I didn't mean to scroll like that. Sorry. And John's got his message now as well. So if we tab back to John, we'll see the message being received. And if we have a look at, I'm not sure if I was tracking the network profile there. Oh, I wasn't. So that's pretty much my brief introduction to SignalR. Does anyone have any questions?
Explain the backplane technology.
So what this really is alluding to is, how would I scale this out if I have multiple servers, right? So if I had multiple web servers, how would an event raised on one server, so for example, John types the message hi, gets sent to one web server, however, Andrew is connected to web server 3 over here. How would Andrew get the updated event that John has sent him a message, for example? We'd need a backplane connection between these servers. There's various implementations to this backplane. It can be done on SQL Server, it can be done on, I think we looked at a RabbitQ implementation. There's obviously Azure Q implementations, and it allows the events to be propagated between the servers and information, and basically it allows the system to be scaled out over a large number of web servers.
A bit like managing a session state.
Yeah. A bit like managing sessions.
as an aside, SignalR was so successful that they let the guy that wrote it rewrite the whole .NET framework.
Really?
Yeah. Yeah. This was his little baby before they said, sure, tear up the whole framework. And it's also in current version of Microsoft Office, current versions of Visual Studio to do all the browser linking. It's all SignalR. It's kind of everything.
Any other?
Yes, just one, because in the browser the only thing that you can run is JavaScript. You cannot run other language on the browser. And how it's worked behind the scene is there some Ajax that is calling. I mean, it's a pseudo push from the server, but it's a true connection from the client.
I will start it again. No. So basically, what we've seen a few slides ago was the underlying technologies it's going to use to accomplish these things. So if I can just bring it back up. I'm sure you all want to see the guy in the mankini again. Okay, so here, basically it's going to use WebSockets.
Yes.
If WebSockets are available. That allows a fully duplex communication. So that allows the server to remote call JavaScript procedures on the client. However, if that's not available, it's going to use previous techniques such as server-side events.
Yes, and the WebSocket, when it's active, is something like a connection between the client and the server. So it's always.
So we have a small JavaScript library that's going to maintain that connection for us and manage it, which we've added to our page.
Okay.
It's in modern browsers support this connection.
Okay.
Any other questions, guys?
Does SignalR support advanced filtering capability on the, we have examples of messages to many clients at once or to individual clients? Does it have
So yes, we can have groups of people that are receiving messages, so we can filter them by grouping, basically. On that note, SignalR 2 has come out, and it's got OWIN support, and it's a lot easier to mock some of the. It's easy to mock and test.
Then one of the craziest things about SignalR is the awesome tooling support you get. Because, I don't know if you can see it now, that's the old startup. So when you call a server-side JavaScript function, sorry, a client-side JavaScript function from the server, it just kind of looks like you're invoking the JavaScript function, but it invokes on every client. The syntax is kind of beautiful as you read through it.
Yeah, it's very clean.
Oh, and now I'm calling this on the client, fine. And the exact same function name that you'll call in the server-side code will get invoked on the client.
Just in Facebook, where they can have a million of chats or different groups at the same time, are they working with a push from the server that is pushing all the message on all the user group by chat, or they have a technology that is coming from the client, from what you can think about? I mean, it is working with a WebSocket technology to maintain millions of chats going together, or with a client technology?
There's a client library as well, isn't there? There's a JavaScript client library.
Yeah. For Facebook, I don't know what Facebook's exactly using, so I can't answer that directly, but I assume it's using a similar system where it's going to fall down to, it's going to have a JavaScript proxy client, and then it's going to fall down to what is available with the server and client.
Okay. And in some way, when from the server you push the message to all the clients, you filter by each group, I mean, they use it by...
Yeah, so I could have chat rooms, for example, where I was only sending a message out to the people in the chat rooms, or I could be very specific and only send it out to one user. So I don't always have to broadcast it to every user. No. So that was the. Any other questions? All right. Thank you very much.